Alrighty. So some of these rules are kind of just common sense. So order of integration, and if you think about this, I hope it makes sense. If you flip the order that you go, what happens is it just makes the integral negative. So if I had A over here to B and I had some kind of a curve, okay, if I say to go from A to B, go forwards, okay, think of it as area. If I ask you to go backwards, what that does is it makes the integral negative. I flip these endpoints around. So if you reverse the order of integration, you get the opposite answer. 0, I hope, if I say integrate from A to B, it means you begin at A and you end at A. Do you have a figure with any area? No. Okay, so that would be 0. I think I alluded to this yesterday. If you see a function, what you can do with that number is you can pull it out to the front. So we did that with the sine yesterday. I think I had 2 sine of x, that 2 out to the front, and we still did the sine of x. Look carefully at this. Let's say I have 2 functions, f of x and g of x, okay? And I have their integrals from a to b. I can break those apart. So I can do just the integral of f of x plus the integral of g of x. Does that make sense? Okay. I want to point out to you, this is addition and subtraction. Do you see anything about multiplication and division? Okay, you may not do this with division. You may not separate that. There is no such thing. Well, there is, but it involves some complex stuff that we don't even get till chapter 6. Same thing, we can do a constant where we multiply, but you can't do it with 2 functions. There is a way, it's called integration by parts. There is a way to bring up product rule or reverse product rule, but it isn't by just multiplying the integrals together, okay? So just try to be careful that even though this makes sense, let's not start trying that it doesn't. Not division, there's no division, and there is no product rule with 2 functions. This one. All right, let me do a visual. Draw. We're going to draw our f of x, okay? And then I'm going to do A, B, and C. Okay, so I hope it makes sense to you that if you did the integral from A to B, I'll highlight that in yellow, okay? What would this area be if I highlighted it? Highlighted in a different color. So if I wanted to do A to C, don't you think you'd just add those 2 integrals together? Okay. You should be able to play around with this statement though. For instance, let's say I gave you the whole area and I gave you one of these 2 pieces. What would you do to find the other? Subtract it. Like if I gave you the integral from A to C, for instance, and then the integral from A to B, couldn't you take the integral from A to C, A to B, and get B to C? Okay, so you should be able to work with this. All right, let's see if we can put some of these into practice then. Okay. And you can even state them by number if you want. Above, which rule is this an example of? Some difference. Okay. So if I want to do the integral from 2 to 6 of f of x plus g of x, what I can do is, and I'm going to write it out the first time. Actually, my kids who go on to college calc tell me that some of their professors are super, super nitpicky about writing the in-between stuff, even though in our heads we're right? But this is what this means. Oh my goodness. Are you given both of those integrals above? Yeah. So what do I do? 10 minus 2, which is just 8. Okay. For me, guys, you don't have to write that in between stuff every time, but just be aware if you're going to move on in calculus, some professors write out stuff like that, like what rule it is. Okay, it works with subtraction too. So what should I do here to find this integral?
Just with the subtraction sign.
So which one, though, comes first? So negative 2 minus 10 would be negative 12. All right. What is C an example of? So this is the same thing as 3 times the integral from 2 to 6 of f of x dx, which is 3 times 10, or 30. Okay. Let's just double check. This is 0 to 5 and this is 5 to 7. So 0 to 5, 5 to 7 is the function the same? Same function, right? What is implied then? What else could you tell me?
That 0 to 7, 0 to 5 plus 5 to 7.
Yeah. It's 13, isn't it? Okay. So that's what this question asks. The integral then from 0 to 7, I'll write my in-between step if you're not quite picking up on it, is the integral from 0 to 5 of f of x dx plus the integral from 5 to 7 f of x dx, which is 10 plus 3, or 13. What is B an example of? Which property of order of integration? We don't have 5 to 0, but we know 5 to 0 is the opposite of 0 to 5 dx. So it would be the opposite of 10. What is C an example of?
0.
The 0 property, okay? From 5 to 5, that would be 0. All right, how about D? What do I do with D? So bring the 3 to the front. It's the same as 3, 0 to 5, f of x dx. So 3 times 4, 30. How are we doing with this stuff? Okay. Oh, I just love this part. So now, I love this because we start to get into things that you see. This is like, you see this on AP exams all the time, where they ask you to do a bunch of things with this. They do things with derivatives with this, like slopes of lines, okay? But now I'm going to ask you to do things with integrals with this. And so what concept can I use? Area. Let's keep in mind, even though there's no such thing as negative area, if the area is below the axis, we're going to make the integral negative. Okay? So 0 to 2. Let's look at 0 to 2. I'm going to shade it. That's a quarter of a circle, agreed? Okay? So I'm assuming the scale is as is, so the radius is 2. So I'm going to take pi r squared divided by, that's pi times 2 squared divided by 4. Doesn't that just come out to be pi? All right. Oh, I'm going to have to color code now. How about 2 to 6? Let's see. That's, I'm going to just do, oh crap. You guys, I just said this and then I ignored it. What did I do wrong? In the first one, Alec? Yeah. It's below, that should be negative pi. Okay. This is a triangle. What's the formula for triangle? 1/2 base times, so we have 1/2 4 times 2. The area, and it's above the x-axis, the area is 4. All right. How about negative 4 to 2? That's this whole thing. Now, I'm going to be smart about this and use the fact that, didn't I already find a quarter circle? Okay. So by the way, these are going to be, it's going to be negative, okay? Which is 1/2 2 times 1. And then plus pi, quarter of my circle. Oh, that's bright, isn't it? Makes you squint a little. I won't use the pink anymore.
Is it minus pi?
Well, I'm going to do around the whole thing that way, okay?
Yeah.
Is it both of the circles?
Yeah.
Poop.
Yep.
Thank you. So I'm going to answer as negative 2 pi minus 1, right? Okay, am I running out of colors? I'm not. Do you like pink? Oh, cool. I already did a bunch of this work. How about negative 4 to 6? Let's add them all together. It would be all the way from here to here. So we have negative pi minus 1. That's from here to here, right? Plus 4. So it looks like I can simplify that to be negative 2 pi plus 3. Okay. Oh, love this question. Okay. You have to be careful. There is a difference between asking this question, and I'm going to write here, this is not equal to this question. Can anybody tell me why not?
It's not a rule on the other side of the table.
No. It has to do with the order in which you would do those two things. This statement means do what we did here, and then at the end take the absolute value. This statement means the integral of the absolute value of f of x, which technically means I would make these things before I started all positive. So I can't do the end result, I have to break it up. I have to take this guy and make it positive, this guy and make it positive. This one is already positive, okay? Area of this piece, 1/2, 2 times 1. Well, value of this right here, is that the same as that? No. Okay, this is a bracket. This is a bracket. What do you think would happen if I moved this function up 2?
The area would be positive and
Okay, I'm going to break it up to you. This is the same as this. Plus this. Do you agree with that? According to my rules, isn't this integral the same as that plus that? Okay. Did we find this anywhere? Where did we find that?
letter D.
In letter D. We learned how to do this the other day. This is just on a line at 2. Let's draw a little picture. Horizontal line at 2. From -4 to 6. This is a rectangle. So -4 to 6 is 10 times 2, so plus.
But it's 83.
Yes. Good thing it's a Friday. Gotta rest my brain. Okay. Now, part E above gives a way to find the total area between the x-axis and the function between -4 and 6 without using absolute value sign expression that can be used to find this area. Okay, so can somebody basically tell me another way to do that without absolute value signs? You can pick it up if you want to. What do we have to do to this area? So what sign would do that? The opposite sign? Right? Okay, so is it one way I could do this to make it the opposite of the integral from, what was this, -6 to 2? Because that's all negative, but I wanted to make it positive. And then I would have to add it to the integral from 2 to 6 of f of x dx. I'm asking you to redo this without using an absolute value sign. So what we could do is we could evaluate this integral because we said it was negative, make it positive by taking the opposite. Anybody want to get really a lot more complex? And did you notice another way you could do it then? Just to be fun. Isn't there something that does that? Instead of doing the opposite, isn't there something we can do to do that? One of our rules? Flip the order of the integration. So if I wanted to make it the opposite of this, instead of putting the negative, I could write it as 2 to -6 f of x dx.